Bismillahirrahmanirrahim. Welcome to my channel Science and Engineering Knowledge Academy. I am Afnan Haider Khan. Today we are going to discuss measurement. Now, what is measurement? So, whenever we compare an unknown physical quantity with a known or standard physical quantity, so this process is called measurement. So, basically, measurement we have one known quantity what we call standard. So when we compare an unknown quantity with that known quantity, right? So after comparison, we can see or we can find this unknown quantity because of this known quantity. Now this entire process is called measurement. For example, if we have a balance, right? One pan, another pan, and there we put a standard 1 kg. So when we compare it and we put anything over here, when both these pans are balanced, so we call it as 1 kg both on both sides, right? 1 kg on both sides. So what is measurement? So measurement is basically the comparison of an unknown quantity with a known quantity. Now, in the measurement process, basically there is a measurement system as we have discussed. It can be a um, balance, right, to find out the mass. So it can be any system, right? So it can be any measurement system, right? And for this system there is an input, right? And then we compare that with certain standard. So we provide a measurand. What is input? The input is called measurand, which is an unknown, right? It is unknown, and this is standard, which is absolutely known, right? So after passing or after using this measuring instrument or this comparison process, we will get a result at the other end, and that's how we would know this measurand would become a known quantity, right? So we'll get an output over here. So this is the most simple process or simple explanation of how the measurement works. So we provide standard, known quantity and unknown quantity measurement to a system or to an apparatus or a measuring system, which gives us an output, right? So obviously to find out different physical quantity, this instrument or this system would be different, right? Which we will be discussing in the future. Now, what are the measurement units? So we all know that measurement units are of two types. One is fundamental or standard units, and the other are derived units. So why the fundamental units are called fundamental or basic units? Because they are not derived from any other unit. They provide base or fundamental uh, quantities to the derived quantities. They are not derived from any other quantities. In fact, they provide the base for the derived quantities or derived units. Or derived units are those which are actually derived from the fundamental units by either multiplying or dividing two or more fundamental units, right? So this is how we get derived units. So standard units or fundamental units do not require any other unit or any other quantity to be dependent on, because they provide the base for all the measurements and all the units. And derived units are those which are actually derived from the fundamental quantities either by multiplying them or dividing them. So we'll get the derived quantities. Now, there are 7 fundamental quantities: length, mass, time, electric current, temperature, luminous intensity, and amount of matter. These physical quantities have units: length meter, mass kilogram, time second, electric current ampere, temperature Kelvin, luminous intensity candela, and matter mole, right? And these are the symbols in this right column. Other fundamental units are related to the angles, basically what we call for supplementary fundamental units, and that is a plane unit and a solid unit. The plane unit, we have plane quantity, we have the unit radian, and for the solid, which is 3D, the unit is steradian. This is 2D unit, and the steradian is a 3D unit. Right? Now all other quantities are basically derived from the multiplication or division of these quantities, or the units, derived units are derived from the multiplication or division of these units. How? Let's see. uh, Here, right? This is area. You see it's square meter. So because it's meter into meter, so the multiplication of the length or into breadth, it basically gives us meter into meter, and that's meter square. The square meter, that is cubic meter. Meter per second for the velocity, acceleration. So all these quantities and many others are basically derived quantities, where their units are basically obtained by the multiplication or the division of the standard units, right? Now, to define the standard units, there are certain standards which is accepted worldwide, these definition, and they basically are accepted in today's world after an evolution, after passing through an evolutionary process, right? So today what we have a definition of meter. So 1 meter is the length of a path traveled by light in an interval of 1 hour, 1 by 299,792,458 seconds. So it's almost 1 hour, three 30,000, or I would say 300,000 into 1000 seconds, right? Mass is basically the platinum iridium cylinder kept in the International Bureau of Weights and Measure in Paris. Now time is basically the vibrations or the hertz uh, basically produced by the vaporized cesium-133, and how much hertz? It's 1.92631770 into 10 to power 9 cycles. So that's what we call 1 second. So when the cesium-133 produces or vibrates, the radiation vibrates or produces the cycle 9.19 into 10 to power 9 cycles, so we call it as 1 second. As far as the degree or air, we would use the Kelvin basically. So the temperature difference between the absolute 0 Kelvin and the triple point is defined as 273.16 Kelvin or 0 degree Celsius. Similarly, ampere is the current flowing through two identically long parallel conductors of negligible cross section placed 1 meter apart in vacuum and producing a force of 2 into 10 to power minus 7 Newton per meter length of the conductor, right? So whenever there are two long parallel conductors whose cross section is negligible and both of them are placed at 1 meter apart in vacuum, so the force of 2 into 10 to power minus 7 Newton per meter length of that conductor is produced, right? So 1 ampere is the quantity of current which is passing through that particular conductor between the two conductors per meter length basically. Similarly, luminous intensity has candela. So 1 candela is the luminous intensity in a given direction from a source emitting monochromatic radiation at a frequency of 540 terahertz and with a radiant density in that direction of 1.4641 milliwatt per steradian, right? Where one steradian is the solid angle which having its vertex at the center of the sphere cuts off an area of a sphere circle equal to that of the square with sides of the length equal to the sphere radius. These are the units which we have discussed already in the physics, right? So all these definitions have been discussed in the physics, particularly the steradians and all the fundamental units. As far as the mole is concerned, so the number of atoms in a 0.012 kg mass of carbon 12, which is the isotope of carbon. So the number of atoms in 0.012 kg mass of carbon 12 is called 1 mole, right? So when we are discussing the physical quantities and the units, so we should know what the unit means, or what does that unit basically indicates. So I'll left it for you to study and to remember these units, to remember these units as well as their definitions, and to understand that what is the difference between the physical fundamental physical quantity and the derived physical quantity, and how by defining these 7 units we can actually have an idea of different derived units. So we would not basically be required a particular definition for the other derived units if we know the definition of these 7 units, right? Now, how we actually design a measurement system. So a measurement system exists to provide information about the physical value of some variable being measured, right? So obviously we need a measurement system, as we have discussed, to give us the information of a physical quantity or a physical value of some variable which we want to measure, which is measurement, right? As we have discussed, there will be input and output, and then there is a measurement system. Now this measurement system can be comprised of at least one component or more, one component or more, and these components are called elements of the measurement system. Now measurement systems have these elements, so it can have only one element, that is direct sensor, which gives us the value, right? So it can be one element, right, one component. You give an input to the particular sensor and it will give you the output. For example, if we have a thermometer, so it has a bulb which has a mercury, and that mercury rises over the scale, and it gives us the value of the temperature. Similarly, if that sensing element is not giving us a value directly, so sometimes we need to condition those signals which are being received by the primary sensor or primary element. So it passes to the signal conditioning element, and then those signals are processed by another element, and finally we have a data presentation element, or display, or any kind of a graph through which we can actually measure that value, right? So I'm going to discuss the elements in detail. So first of all, we would need a primary sensor. So the input value, the unknown value, would be received by the primary sensor, and then it would basically transfer it to the variable conversion element, where here the sensing value would be converted into a particular variable, where it would be processed in the next stage, and this is what we call signal processing. So the sensor would receive the signal, and then it would be converted into some particular type of a signal, right, where we actually convert that signal, and then that signal is processed, such as we use the amplifiers, and such as we can actually use the different types of tools to basically process that signal. And sometimes we basically send that signal to a remote area, to a farther area, through a signal transmission. So the signal transmission has been done to a remote area, and then there is a signal presentation or recording, such as display, such as the recording, such as the graphical representation. So all these comes under the signal presentation or recording, right? So these are the major components of the measurement systems. It can be one component only, just sensor. It can be two component sensor with a variable conversion element, where we can actually convert that signal into the required or the desired form. Then there is signal processing, where we can actually amplify the signal. We can we can basically play around with the signal and process it so that we can have a good data or a clear data. We can reduce the noise from the data, right? So ultimately we have this output display where we can get the readings, required readings of the unknown value. So this input value unknown is basically being known or being displayed over here in this section or display, right? Or it can be in the form of recordings, such as if we receive recordings from different galaxies outside the outside our in the outer space. Now this primary sensor and the variable conversion element, when combined together or work together in a single as a single component, so we call it as a transducer, right? And when these two components are combined with a signal processing, and then that thing is called transmitter, right? So sometimes in one component these three elements combine together to make it a transmitter, or these two components can combine together to form a transducer. Now, what are the applications of the measurement system? So, measurement system applications can be divided into three main schemes. One is for monitoring of the process and operations, and the second one is the control of the process and operations, and the third is the experimental engineering analysis. And we are going to briefly discuss each of them very quickly, just to get a basic idea how the measurement system, or we can say that what would be the applications of the measurement system. So first, monitoring of process and operations. So the basic function here is that measuring instrument is characterized having an essentially for monitoring purpose. It can be only used for monitoring function, such as the weather bureau have the thermometers, the barometers, the anemometers, where they find the temperature of the and temperature, pressure, humidity, speed of the air, where they just monitor that, right? There is no other step being taken in that bureau just to monitor the weather, right? And there is no control function in the ordinary sense. So ordinary, there is no control function performed by the weather bureau. Just they have the purpose of monitoring using the instrument, measuring instrument, such as thermometers, barometers, and anemometers, right? So these are just the measuring instruments used in an application where there is only monitoring of the process and operation. Similarly, we have water and gas and electric meters in our home that actually keep the track of the quantity of the commodity used, so that the cost of the user can be computed, right? So this is another example. Similarly, the film badges worn by the workers in the radioactive environment basically monitor the cumulative exposure of the wearer to the radiations of different various types. So they all of these equipments or all of these measurements do not have any control function, right? There is no control function, there is only monitoring function, so that in case of any uh, um, uh, I would say errors, or in case of any alarming situation, so that we can actually um, keep the track record of the quantity rather than making the corrective measurements or control measurements within the system, right? So this is not performed by the particular device. For example, electric meters have nothing to stop or have a controlled function, right? Modern electric meters might have this capacity, but in general, the electric meters and the gas and water meters have the ability to basically keep the track of the quantity of the commodity used by the consumer, rather than taking any control measure in case of any mishap or any kind of a signaling or any kind of a controlling, right? Similarly, the other is controlling. Obviously, whenever there is a control, so we would definitely need a feedback system, such as in the water heaters, we have a feedback system where the thermostat acts the way it gets a feedback. For example, if we have set a temperature of a room right? Over here, temperature of a room. So we would put the reference value over here, and then there is a comparator. So that comparator will basically turn this heater on and off depending upon this temperature measuring device, right? So our basic temperature measuring device is installed in the feedback loop. So this entire room temperature will be controlled or reach when it reaches to this reference value. So this comparator will turn this heater off, and when this value is less than the reference value, so this comparator will turn this heater on, and that's how this process is basically controlled. So here this temperature measuring device is not only measuring the temperature, but it is actually providing the feedback which is used for controlling the system, right? So this is another application of the measurement system. And the third, which is a basically broader area where the measurement instruments are used for experimental engineering analysis. Obviously, when in the field of engineering we require measurements, we all depend upon the measurements, and that measurements are basically conducted or used through instruments. So to form the to solve the problem, and to perform the experimental engineering analysis, we definitely need measuring instruments, right? Now, what are the different type of experimental analysis or problems in which we can use different type of instruments? So for example, testing the validity of a theoretical prediction, right, based on simplifying assumptions, improvement of theory based on measured behavior, right? So sometimes we have theoretical prediction, but in fact mostly we have the theoretical prediction based on simplifying the assumptions. There are a lot of assumptions, but in practical, when we measure the values, so we can actually improve that theoretical the predictions or theoretical behavior or theoretical the theories related to the different kind of concepts, right? Different kind of engineering analysis. Example is the frequency response testing of mechanical linkage for resonant frequency. So there is a theoretical base, there is a testing base, there are theories related to this, but to perform testing on these mechanical linkages, we can actually find out the exact frequency response behavior of that particular system, right? Or we can use the formulation of generalized empirical relationship in situation where no adequate theory exists. So sometimes we in a research work we basically generate the generalized empirical relationships to determine the behavior of a particular system, for which there is no theory or pre-existing information available in form of a theory, right? So we or in form of a journal behavior, so we actually can formulate a journal empirical relationship in that case. Then we have the determination of materials or components and system parameters, variables and performance indications. So obviously the determination of the yield point of a certain alloy, speed, torque curves on a motor, electric motor, thermal efficiencies. So we can actually find out the behavior of the material, the components of the material, right? Using the different kind of testing, to perform different kind of testings, different kind of the indices we have set for different kind of materials and different kind of systems. Then study of the phenomena with hopes of developing a theory. So for example, the electron microscopy of metal fatigue crack. So we can actually perform we can study using the different kind of instruments and measuring instruments to find out the here the electron microscopy can be used to find out the or to study the metal fatigue cracks and how they propagate, what are their behaviors. So actually we can use that measurements to predict a particular phenomenon, and we can hope to develop a theory based on those measurements. And last but not the least, solution of mathematical equations by means of analogies. Solution of, for example, solution of shaft torsion problems by measurement on soap bubbles. So we can basically solve the mathematical equations through analogies, and for that analogies we need some kind of measurements and some kind of relationship. or I would say the analogy between different kind of materials or different systems to behave in a way where we can actually prove that both the equation, the mathematical equation, has the analogy with another system which is not necessarily an engineering system, such as the soap bubbles. So we can also use the experimental engineering analysis, and all these would be depend upon the measurements, right? This all this depend upon the measurement and measurement instruments. So this is the widespread application here. The widespread application of the measurement system can be seen and can be witnessed. These are each of them actually, the different type of analysis problem, each of them can be discussed separately with more and more and more detail. But for now, we just want you to understand that these are the different kind of scenarios where the experimental engineering analysis can be done, and the problems can be solved or analyzed using the measurement instrument. So this is another application of the measurement instrument. So we have three basic uh, applications schemes: monitoring, control, and the experimental engineering analysis. Well, thank you so very much for watching, and for more videos, subscribe to the channel and hit the bell icon. We are going to discuss more problems in the coming lectures, so stay tuned. Thank you. Bye bye.